right, so this is one of those questions you've got to be comfortable doing with me, for me. It says at 25 degrees Celsius, the KSP of lead 2 chloride is that, and the KSP of silver chloride is this. This question has nothing to do with silver chloride because silver's not mentioned. Yes? Okay, so I'm going to ignore that silver chloride information because notice there's an I, an II, and an III. Right? Okay, so I'm going to ignore the silver for a while, and I'm only going to focus on this right here, KSP for lead 2 chloride. Now, what I says is, if 60 milliliters of a 0.04 molar NaCl is added to 60 milliliters of a 0.03 molar PbNO3 taken twice, all right, so I have one source for chloride, I have one source for lead, 2. I'm going to ignore completely sodium and nitrate. They're going to spectate anyway. They're always going to spectate, so I'm going to ignore them. I'm only going to extract or pull out the chloride from the NaCl and extract or pull out the lead from the lead 2 nitrate. Okay, so here's what you have. You have 2 beakers, sodium chloride and lead 2 nitrate, yes? And I'm only interested in the chloride from this one and the lead 2 from this one. And I want them to be in the same place because if they're not in the same place, they can't try to do anything together unless they're in the same place, yes? Okay, so first things first is I've got to say 0.06 liters times 0.04 molar to give me 2.4 times 10 to the minus 4. Is it 3, 4? Minus 3. Okay, minus 3. See, if we would put it in scientific notation, we could do it without a calculator, right? Sure it's minus 3? Okay. Moles of NaCl. Now, I'm going to rewrite that as 2.4 times 10 to the minus 3 moles of Cl minus, because I could care less about who? Na. It's going to spectate. And the reason I have the same number of moles of chloride is because for every 1 mole of sodium chloride, there's 1 mole of chloride, yes? Okay, Matt, stay with me. I'm going to do the same thing, 0.06 liters of a 0.03 molar, and I'm going to get 1.8 times 10 to the minus 3 moles of PbNO3 taken twice. Yes? How many moles of lead does that give me? The same, 1.8 times 10 to the minus 3 moles of lead. Now, quick question. How many moles of nitrate would it give me? I know it's not going to matter, but they could ask you that question. Twice as much. So what's twice 1.8? 3.6. 3.6. So I'd have 3.6 times 10 to the minus 3 moles of nitrate in case they asked me. All right. Now here's the deal. What are those mole values sitting in now? How much? 120 milliliters or 0.120 liters. Okay, so this is what I want you to write down. We're going to write down PbCl2 solid on the left in equilibrium with Pb plus 2 and 2Cl minus on the right. Because I am asked, will a precipitate form? And notice they didn't tell me of who, but they already gave me information up here. And the only 2 precipitates I can think about being made are lead 2 chloride or silver chloride. There is no silver here, so there's only one choice. Solid on the left, ions on the right. Solid on the left, ions on the right. And this is a question. These Q questions, Matt, mean that you're always starting, Matt, you're always starting on the right side. So you're starting with 2.4 times 10 to the minus 3 moles sitting in 0.120 liters, yes? Yes? And you're starting with 1.8 times 10 to the minus 3 moles sitting in 0.120 liters, yes? So the question is, there's no precipitate yet. There's no precipitate. You took a completely soluble aqueous solution with another completely soluble aqueous ionic compound. There's no solid anywhere, yes? There's just water and ions floating around. There's 2 ions here, 2 ions here. I poured them in there. There's 2 ions that matter, and there's 2 ions that don't, floating around in total volume. There is no solid yet. Because what we've done is we've said, pour them together, stop the clock, and let me decide before they do anything, will they do anything? So here I am. This is called initial. Really? Yes. Because this is not trying to take some solid, stir it up, and see if it will dissolve when it's insoluble. This is, I'm taking 2 ions from 2 separate sources and putting them into one place. This is a big question that we're going to come across. You're going to see it on your test sometime. It's called Q question. And it means I'm starting on the right with ions. And the question is, will I have a precipitate? I don't know yet. I can't answer that question yet because I haven't done the math yet, called Q, so that I can do a comparison of KSP to Q. So did you have Q in chapter 13? Most of the time, that was where you just had molarities or moles per liter of all your reactants and all your products. And you had to decide which way it shifted. 99% of the time, which way did it shift? Right? Well, here, totally different. I have only ions, which means I only have products. And the question is, are you going to have a precipitate? And you can't say yes because it's insoluble. You wanted to say that. You wanted to look up on the owl and say, well, look up KSP and it's insoluble. So yeah, there's a precipitate. No, because KSP says, I will allow a few ions to be floating around, but no more than. No more than. All right, so how do we figure out no more than? We call it Q. Now, this is what Q is going to look like. Q is going to be lead times chloride. And what do I have to do to the chloride concentration? I must square it. I must square it. Okay? So I'm going to plug in my numbers. Somebody give me this number out. Who's got 2.4 times 10 to the minus 3 divided by 0.120? 0.02. And what is 1.8 times 10 to the minus 3 divided by 0.120? 1.5. Okay? Squared. Okay? And what do I get for my answer for Q? Yes? Did everybody get that? Okay, what'd you get, Brianna? 6.0 times 10 to the negative 6? Fine. Since we're videoing, we better get it right. Okay, that's fine. You don't have to write it in that order, so let's rewrite. 6.0 times 10 to the minus 6. So this first one is 0.015 molar, and this one is 0.02 molar squared, which gives me 6 times 10 to the minus 6. So let's do a KSP. KSP is 10 to the negative 5. Who says? KSP does. And how does that compare to Q, which is 10 to the negative 6? KSP is bigger, so this is how I write that. So which way is my arrow pointing? Towards the Q. That means I don't have too many ions floating around. That means I don't have a precipitate. So those of you that just looked at KSP and said it's insoluble, so yeah, I'll have a precipitate. You didn't do math. You got to do the math before you know whether there's a precipitate or not. What are you scowling at, Scott? You want it to precipitate? Well, if Q were bigger than KSP, the answer is it would precipitate.